So welcome everyone, and let's talk about performance. I would like to start with a claim that for every website out there, there's at least one user who perceives it as slow. I mean, if you've ever built a commercial website, you probably know this, right? And we have been there as ROI Hunter as well, at ROI Hunter as well. From time to time, we get reports from our users that the web is just slow for some reason. And at the screen, this is our analytics part, but we also have a big ads creation flow, a huge multi-step form, many elements, all interactive, dynamic, and everything. And that's really easy to introduce a subtle performance issue. So in this talk, I would like to tell you how we are trying to get control of those and what maybe you can do to do it as well. A common theme for user reports like that is that they are incredibly vague and unclear. And that makes sense, because users are not as technical as we are. So let's go quickly through the basic reasons there are for a slow performance. Network speed, this is super obvious. You have some data, you need to get it to your clients, and that can be somehow improved if you place the data closer to the client. Maybe you would use a CDN. Next, if your web is not fully static, you have some backend, and that backend takes some time to respond. To measure this and to get ahead of that you would probably use some server-side measurement at the closest to your app. Your user's environment, on the other hand, this is a super tricky one, because unless you are a bank or some government organization, you have no way of forcing any specific hardware or software onto your users. So reports where something is slow, maybe because the windows haven't been updated in years, that's really hard to track down. Front-end speed, on the other hand, this is fully on you. This means how you write your code, what data structures you use, what algorithms, how you structure the whole app. And this is something we'll be focusing on today mostly. And also an honorable mention goes to UI and UX, because although your app may be technically super fast, by poor choice of UI, it can seem slow. Let's say your fade-in transition takes a long, so that may be another reason you can easily miss. So I was talking about a regular user. What they all see, what they tell you is that your front end is slow. That's just it. In fact, you can split that down into two main components. That is the initial load, and then there is everything else. For the initial load, you can use standard stuff like Google Analytics, and that leaves the rest as the hard part. I would call those interactions, because that means anytime user somehow interacts with your web page. That's what we'll be talking about. And if you think about it, based on the definition, which you choose later, those interactions can also include network speed, the environment. Let's say the user is sitting in a Starbucks on some poor Wi-Fi, or maybe sitting on a cable internet in some corporate. The environment, if the CPU is melting, it probably won't perform as fast as it would otherwise. So, and obviously it includes your code, right? So this seems like a nice opportunity to measure the overall performance. And there are studies saying that if your interactions happen under 100 milliseconds, they will be perceived as instant. And this is interesting, because if you manage to get all your interactions to happen in that budget, the app will seem to be basically a desktop app. And interesting fact is that the first asynchronous version of Gmail was built with this rule in mind. So they aimed for all interactions to happen under 100 milliseconds. So for us, with measurement, that means we have a budget to fit in, if possible. Now, what are interactions? The answer is it heavily depends. It depends on you and how you choose to look at those. You can think of interactions as like a time since user does any input, clicking a button, typing or something, until the time the page responds. So super simple interaction would be clicking a button and a loader showing next to that button. That's just it. That was the whole interaction. You can also choose to see it from a different point of view, where user clicks a button, that's where the interaction starts. Then a loader shows up, you fire a network request, you fetch the data, render it, and that's where the interaction ends. And that interaction would mean something a bit different. It would span for the whole intent, like fulfilling the intent of the user. And you need to be pretty careful about what to choose, because you would be measuring two different things. In the case with the network request, you would be measuring the user experience more. And in the former case, with just showing the loader, you would be mostly focusing on your front-end code. So to start, I would suggest starting with the simplest one, with just showing, like clicking the button, showing the loader. Because if that interaction is slow for you, you have a big problem anyway. Now, how can we start measuring? Anytime you say, I need to measure something on the web, probably there's another guy saying, hey, use Google Analytics. And that is completely fine. It's became the tool for measuring web performance. And you probably have it integrated anyway, so why not? A great thing about it is that it supports the initial page load very well, proven by years of practice. And if you're building a modern single-page app, there can be some issues with measuring a later navigation, like after the app loads fully. There are some extensions to Google Analytics tracking code that you can use, but you can also choose to look at this from a different angle and say, the app had loaded, and now everything else is an interaction. Even navigation is an interaction because user clicked and something has changed. And if you take some single-page apps, such as Google Calendar, for instance, it can be hard to say what is and what is not a page load. Let's say I have a monthly view of my events, and if I switch to weekly view, the URL changes, sure, but there was no network request possibly. So was it a new page load? Was it not? I don't know. So once you figure out boundaries of those interactions for your app, you can simply put some timestamps here and there, calculate the difference, and send it to Google Analytics as a custom event. You can add some parameters to say this was my interaction's name, and that would be a pretty okay solution, something to start with. There are other tools that provide the same or even better experience. They often call it real user measurement, but the approach is typically the same. You need to include some tracking code, put it at the beginning, at the end of your interactions, and you need to often do it one by one. To improve that, I'd like to show you how we are doing that, and in order to explain it in detail, I need to show you a few new concepts first. Starting with React itself. If I was talking about measuring your front-end code, in React world, that would mean your component's lifecycle performance. And that can be tricky to measure, and React team is aware of that, which is why they introduced a profiling API. It has been around for about a year now, and it has recently been promoted to stable release in React 16.9. And what it does is that it adds a new component, specialized component called profiler. And anytime the profiler's subtree renders, the profiler will be notified to the callback, and it will receive the performance data. To somehow describe the data, you would know that React lifecycle has some update phase and render phase, and for the purpose of profiler, React combines those two together and calls it commit. So basically, commit means one run through the lifecycle. And in that data, there is a property telling you if this was an initial mount, or if that was just a further update. That can be interesting for you. If you maybe wrap your router component with this profiler, you can see when the subpage mounts for the first time, because you expect it to be maybe a larger render or larger commit. Also, the data contains, and that's probably the most important property, the actual time it took to render that update. Be it mount, be it update, whatever. Also, it includes some estimate for the worst case scenario, and that is estimated by React itself, and based on the difference between the estimation and the actual time, you can tell how well you are using optimization techniques such as should component update or memoization. So this is an interesting thing to keep an eye on. Obviously, using profiler in production can mean some extra overhead. And React team is aware, they tell you that, but they also work to minimize that as much as possible. There were many commits, many pull requests, in optimizing that, removing stuff like unnecessary allocations and others. And there is even a bundle with profiling enabled that you can use right away. So it's not like this was something forbidden, something you're not supposed to do, but it's like very well documented, and the general guidance is that you should use as few profiler components as possible, because the overhead grows with how many instances of profiler you use. Ultimately, that decision is on you. We haven't observed any noticeable slowdown, but really depends on what is the type of your app and if that makes sense for you. Now, this is all nice, but you may be asking, why cannot I just use the timestamps, calculate the difference, and be done with that? The thing is that under the hood, React does many optimizations, and you may not be measuring the real time. There is a big change coming in, hopefully next year, that is called concurrent mode. And in that mode, React will be able to pause update of your component, run some other updates alongside with it, and then resume. And if you would be using just the timestamps, you would also include the time it has been suspended. And in the end, you may be chasing a performance issue that had never been there. So with that in mind, Profiler is built to be really inside of the React internals, so it's aware of all those current and future optimizations there are. Now let's see how you can define the boundaries of your interactions. Besides Profiler API, there's another package called interaction tracing. As you can see from the imports, it's still marked as unstable. That just means its API can change. It is still okay to use, so you can go ahead. And the goal is simple. If you are using just the timestamps, you would also need to somehow mark down the interaction data, somehow say like this interaction means clicking or something. And you would need to preserve that data, that context, throughout the whole stack. This is basically what this trace method does. So you give it the name, you give it a performance.now, and everything that happens inside of that callback will be attributed to that interaction. A nice thing is that it also supports asynchronous context, which you would also need to otherwise handle yourself. That would be, for example, if you're doing a network requests, if you decided to include those in your interactions. So this simple method wrap basically takes the asynchronous context and includes the outer interaction data into it. And what is the most important, this plays very nicely together with the profiling API. So anytime there is an interaction going on and your profiler receives a commit data, the interactions will be included. Now, okay, going back, you can see that in this case, I still need to put some extra code into all of my handlers every time I need to measure something. There is a better way of doing that, and that is with Redux. Chances are that if you're using Redux, your user actions are basically dispatching Redux actions. If that is true for you, you can use this simple middleware where your actions are wrapped inside a trace. We have this nice built-in direction name method that just pulls out the action type and some other parameters to make a nice name. And with this, you no longer need the handler code at all. So this is the only change you need to do in your app. A nice thing is that with this, you don't even need to use more than one profilers. You can only use this one top-level profiler that spans the whole app, and it will be notified of any changes that are happening. So that means that the overhead should be the minimum. So now let's see a real-life example. This is one of our pages. There's a button where you can customize the columns. There will be in a table. And I can tell you, showing this model takes a long time. So let's see how I got to know that. I hope you're familiar with this. This is a developer tools extension for React Profiling. And because we enabled profiling in our production bundle, we already can see the profiling data. What is great, we can also see for the bars at the top, those are my commits. If I select the commit, I get to see the details. And on the right side panel, there is also the interaction, the show submodule with the module called edit view. And this is already a great start, a great help for debugging and profiling. But we can go one step further, and we can click the interaction tabs at the top. And doing this, we're basically grouping the commits by interactions. Now, there's this show submodule interaction, and next to it, there's a timeline with its commits. All commits that were attributed to that interaction. So you can see there was a starting commit where some change, probably on click handler. Then there is this gap, and there are 3 more commits after that. Now, because I inspected the code, I can tell you that in the gap, we are lazily loading code of that submodule. The browser is evaluating, we fill it with data, so we can render it. And then there are 3 more commits. But overall, looking at this, you can tell this is a long interaction. And moreover, if you realize that for the longest commits, like for 700 milliseconds, the browser main thread was blocked by our code, which means the browser itself was non-responsive to user actions, which is a pretty bad experience. Now, at the bottom, you can see this console warning. This is our custom code. And what we do is that we calculate the duration of the interaction from the first commit to the last. And if it's above some limit of hours, we just log an error, a warning. Now, at this point, because we are still in production bundle, a developer would probably take this to a local development environment and use all the proper tools like full profiler, full debugger, and everything to inspect the issue, this performance issue. But once again, we can go one step further, and this is the final piece of the puzzle, because we don't want our clients to check their consoles, obviously. We need some automated way to collect the data. And this is why we are using Sentry. Originally, Sentry is a tool for collecting crash data, error logs, and this type of data. But you can also send in anything custom. So, for example, our slow logs. And if I were to compare it to Google Analytics, Sentry is more focused on the context. Analytics gives you nice numbers, so I would be able to say what is the average time of this interaction. But if you think about it, it doesn't really matter. To us, we have this limit in place, and anytime an interaction is taking longer than that limit, I already know that's an issue. I don't care if this was 1 second, 2 seconds, or more. We just need to go ahead and fix it. And the nice thing about Sentry is that, as you can see the message down there, it shows the exact duration it took for this interaction, and different users will definitely have different times. But Sentry, with some little help from our side, can group the similar interactions together and tell us how many users were affected, which is nice for prioritization. So on the top right corner, you can see that this issue has already affected 2 different users on 3 unique occasions. I can also see the first time it was noticed by Sentry, the last time it has been seen so far. I can even see which release most likely introduced this performance issue, which is super powerful. And there is also an automation where, based on the URL, based on the interaction data, and the other context, I can assign this issue to a specific team that is taking care of that part of the platform. And further on, with just one click of the button, I can create a bug issue in Jira or GitHub, and developers can just get on that and fix that. So to wrap it up, we dispatch Redux actions, we wrap them into interactions in our middleware. In our profiler, we collect all the commits, we blacklist those which are of no interest to us, probably because they were not triggered by the user. And we calculate duration of those interactions. Those which are over the limit are sent to Sentry and logged to console. And from Sentry, our developers are fixing the bugs based on that. And that has been all from me. And I hope this inspired you at least a bit. And if you want to get in touch with me, here's my LinkedIn. And that is all. Thank you.